Hi everyone, welcome back. As the title says, in this video, we are going to focus on building an AI-powered video recommender. Of course, we're going to use knowledge graphs, NLP, and also NetworkX in Python. And this is actually building on top of what we have done in the last tutorial. There, it's very similar, except we did not use any AI powered. So we actually hand coded if you not just hand coded, basically hand defined, let me put it that way, a knowledge graph where we said, okay, Python basics, and these are the topics for the video tutorials that fall into Python basics. And then like we defined another topic and we tried to connect these to make sure, okay, we as an expert, we defined a knowledge graph. Now that works fine if you have 10, 20, 30, 40 different topics where you can just sit down and then kind of map them together. As a subject matter expert, you should be doing that. For example, if you're a product manager and if you're trying to see what type of features are used the most and which ones are the central, then you can draw a knowledge graph and you try to connect them. Then manual is the way to go. Now, if you're working with thousands of, well, in my case, I'm going to show you hundreds of videos, but just imagine like thousands of, not just videos, thousands of nodes, right, that you're trying to map, then it gets a bit impractical to actually hand define every attribute that goes with every node and then identify what other edges, what edges are there connecting multiple nodes and all that stuff. So this is exactly, if that's what you want to learn, hopefully you will learn something from this tutorial. And again, if you like this type of content, this would be a great time to hit the pause button and hit the subscribe button. And while you're there, you'll see the little thanks button. You probably never click that, but if you're feeling extra generous, go ahead and explore that. Okay, so here again, what do we mean by video recommender? The only videos that I have access to are my own Python tutorials. So I went to Google. Google has a way of actually, I think it's called Google Keep. There is a way for you to go download your own data. So in my case, for my own channel, I downloaded the metadata for all the videos that I have done until now on my YouTube channel. They are about 400 plus videos. So for each of those, I downloaded the title and the description. And of course, along with that comes the length of each video, on what day I uploaded it. So this is the data set. In fact, I'll just show you a screenshot of the CSV file that we are going to use as input. And of course, there's a lot of text in there, and which basically means we need NLP to extract certain information and then use that information in building our nodes and edges. So let me stop talking and let's go ahead and jump into our Google Colab to start having a look at the code and just walk through to see how I put together this specific code. I'll share the CSV file that I'm going to show you. If I forget, please let me know in comments. I tend to forget sometimes, but I'll share my data with you. And of course, the code, look for the link under the description down below. And let me just show you the screenshot, or actually the Excel file or the CSV file that I just downloaded, right? So it's got like 4 columns, I guess. This is approximate duration in milliseconds, as you can see, which right away tells us we need to convert that into minutes or hours. And then the video description. So you can see if I click on this, it says, hey, if you're a student or researcher, blah, blah, blah. It's a nice long paragraph, like as you can see for some of those. And the video title, I was very good at actually assigning numbers for my videos. Initially, sometimes I skip them. I regret it now, but it's okay. For 95% plus of my videos, I have a number. Why do I say that? Because it helps us in properly defining prerequisite videos. Like you can right away say, hey, if the video number is 24, it's probably a prerequisite to 25. And that's one of the rules. Again, you'll see that later. And when the video got published, and that's pretty much it, right? So we have the key information is video description and video title. And of course, we can also look at the duration to assign some sort of a complexity to a video. Maybe longer videos means, more complex topics. So with that information, let's jump into our Colab. And this Colab document is pretty wordy. The first part is probably worth going through right now, but then it gets pretty wordy down here because I tend to describe each and every aspect of it because I don't know which ones you may be relating your specific project to. But let's quickly go through the first part and then scroll down to our code part. So here we build a knowledge graph, of course, based recommender system for educational videos. In my case, obviously, these are educational videos, and where each node is a specific video, right? So that's each node. So in my case, I'll have 400 plus of these nodes. And then the edges actually capture the relationship. If one node connects to the next one, that's the edge, obviously, and that has a meaning. These are knowledge graphs, meaning the edges have semantic meaning, some sort of a meaning. That actually captures the relationships between these two nodes. So with NLP, we need to automate this process of gaining this knowledge of how do we connect these nodes and what do they mean and all that. We'll walk through that soon. So we start by processing the metadata like titles, descriptions, and duration. We just looked at those using NLP techniques. And in this case, we're going to use spaCy. You can use anything. I mean, spaCy works fine even on CPU, so why not just use spaCy? For extracting key concepts and SentenceTransformer for generating semantic embeddings. Basically what that means is we extract like key concepts based on the title and description. We say, oh, this is a Python basics one, and this is machine learning, this is a bioimage or whatever, satellite imagery. You extract the key concepts, and then you use sentence transformers to generate semantic embeddings, which basically means, hey, for these concepts, convert that into a vector embedding. And then embeddings can help us understand the video relationships, because now you have like all these vectors. All you need to do is find similarity. You can use PyVis, like I mentioned in 2, 3, 4 videos ago, where I did image similarity project, right? Or you can use cosine similarity just to get a number between 0 to 1 and assign that to the edge weight, for example. So we're going to use cosine similarity in our case, and we use that as part of in building our graph using NetworkX. After building the graph, we perform various analysis, right? So once the graph is there, now you can perform various analysis, and NetworkX actually has a lot of built-in algorithms to extract information like centrality, for example, which node is central to the entire learning process. And PyVis is a great visualization package. It's much better than the built-in visualization from NetworkX, which basically uses PyPlot. But PyVis gives you interactive HTML based. It's kind of like, what is that? Oh my God, I'm blanking out, but it'll come to me later. So we'll plot some of these learning paths and topic relationships. All of these are specific names I'm giving to this educational content. A learning path is basically, hey, what are the prerequisites? You have a video. What is the first level prerequisite? What is the prerequisite before that? And before that, how are they connected? And you create a learning path based on what the user's goal is. The user's goal can be in plain English. Hey, I want to learn machine learning using Python. So what you need to do is take that and convert that into an embedding and map it to all the videos that you actually have and extract the relevant ones and then kind of stitch them together in some sort of an order. That's what it comes down to. And visualizing and of course looking at the video prerequisites. And also for demo purposes, I'm going to save this graph or serialize the graph into a SQL database. And then we'll also load it. Again, I don't know what you absolutely need, so I tried to jam too many things into this one video, and I'm pretty sure most of you are very creative in terms of taking that information and applying it to your specific projects. Okay, I think that's enough information, and once we load the SQL database, I included a couple of queries just using SQL querying. I'm not a master of SQL queries, but I know just enough to put together something, and when it gives me an error, we have tools like ChatGPT to help us understand exactly what's going on, right? So, hey, can you fix this? And it can actually do. I tried asking it to write something from scratch, and I don't know. Then you have to give the entire project to ChatGPT and then ask questions. Then you go into a rabbit hole. At least this is in early 2025. So if you're watching this in 2026, maybe we'll live in a futuristic world where everything works right out of the box. Who knows? Okay, so with that information, I'm going to scroll down a little bit. So this part is, I'll leave it to you because we are going to go through this part as part of the code. I included kind of similar information as part of docstrings within each function. So we will cover all of these topics pretty soon. So let's scroll all the way down. You can delete this stuff if you want, if you think you know everything, what's going on. Okay, so the code starts sometime soon. And at the end of the day, we are actually storing our output into our Google Drive. In fact, that reminds me, let me go ahead and connect it. And my drive is right here. Right now, it should be empty. Video recommender, I have results here. But I don't think I have anything in the results, right? So this is where we are going to populate these ones. Database, we are going to save our SQL database there, and visualizations, we will open these visualizations. And also I have a few queries that we are actually, asking, our graph, and those, instead of on-screen text, printout, I am saving them into a text file so we can go through it at our own pace. Okay, so that is the background information, and now let's go ahead and look at the actual code itself. And by the way, some of this summary, I just asked ChatGPT to summarize it. It really, I did a decent job. I had to heavily edit it. So if you see something weird there, yeah, I take the blame. I asked ChatGPT to give me that. So. But sometimes it can be very useful. It gives you some thoughts and ideas like future extensions and possibilities is something it provided. I thought of deleting, and I'm like, you know what, I'm going to keep it so I can potentially do a video on these topics. But coming feedback from you guys is much more valuable than ChatGPT telling me what I should do next. Okay. With that information, let's go ahead and install. All I'm installing here is SentenceTransformer, spaCy, and all the required libraries, as you can see, and the model right there. So let's go ahead and run these lines. I should have been ready by running this, but this should be relatively quick. On Colab, of course, whatever I'm showing you here, you should be able to do it on a local system. I don't see a reason why you cannot do that on a local system. I'm doing it on Colab because it makes it easy, and moreover, my workstation died unfortunately, and I'm on a very old laptop. You can't even tell, from 6 years ago, that I'm using temporarily to get some work done. So there you go. Okay, now that everything is installed, let's go ahead and import all the libraries that we need. And PyVis.network, and network allows us to define the network and do the plotting using PyVis. And yeah, spaCy, sentence transformers, and cosine similarity. I'm using it from scikit-learn, but cosine similarity is available in multiple packages. So I bet they all do pretty much the same, although my experience is primarily with cosine similarity. Okay, so these should be loaded pretty fast. Now let's go through each and one of these functions. So first thing first, we start by loading the data, right? So I called it load video data. It's the CSV file we just looked at. And as soon as I load it, I am going to convert my milliseconds into minutes, because it makes more sense. In my case, because I don't have like a TikTok style few seconds videos, these are pretty lengthy videos, so minutes makes more sense. And also I'm getting the published date, so we can look at the hierarchy of videos. If the number doesn't exist, we have the upload date. So that's one way of actually inferring prerequisites. Okay, and once we load this, there is a lot of text, and sometimes text can have some weird characters. We need to kind of clean it up. And the best way to clean this up is basically convert everything into lowercase and remove all the special characters, extra spaces, and return the cleaned result. And this clean result is what we will be using to extract nouns. Well, I think we should look at the function first. So once the result is, once we have a cleaned text, that goes into this function called extract key concepts, and it returns a list, obviously, as you can see up there. And what is it extracting? Well, we are going to use doc.noun chunks. This is part of spaCy. Actually, it just takes your text and returns the nouns. And we are saying that, hey, these nouns, for example, in this sentence, introduction to Python image processing, here Python, image processing, OpenCV, introduction, they become important aspects in building relationship between videos, right? So we are going to load the text and we are going to split the text and we're going to load the text 3 words at a time just to limit the number of phrases. It's up to you. There's no, this is just what I wanted to limit. And basically extract whatever the noun chunks and then split the text, which obviously by default, creates your list, and it's going to return your concepts. That's it. So this is nothing but we are extracting the key concepts from our own learning content, in this case, my video tutorials. So once you have that, now I define a function called process video data. So what it does is it creates the embeddings for semantic understanding. Okay, so we use this model. I am using this model, all mini LM L6v2. You can use a different model from the SentenceTransformers library. And I'm using it to convert our text into high-dimensional vector embeddings. Basically, we take the text that we extracted earlier, convert that into vector embeddings. In fact, not extracted earlier. Does the text go in as how did I do? Yeah, the video data is actually going in, and we are processing the video data to convert that into embeddings. So we are actually combining the title and description for this embedding process. And once the embeddings are there, we are creating, this is where we have the embeddings, but we are creating a similarity matrix. For each of the embeddings, we actually match it against all the other embeddings, and we say cosine similarity matrix, right? So if one embedding is very close to the other one, then the value is, let's say the weight is pretty high, saying that, hey, these two are very similar. Okay, so what is cosine of 0? When I say 0, that means this embedding are perfect. There is no difference. And when it is 90 degrees, there is 90 degrees offset, right? So cosine of 0 is 1. So when the value is 1, that means both of these embeddings are identical, which almost never happens. Typically, the embeddings are, as you can tell, between ranges 0 and 1 because we're using cosine in this case, which oscillates between 0 and 1, right? Or the magnitude goes between 0 and 1. Okay, so that's that, and then we are extracting the concepts for each video. So how does the output look like in this case, right? So the output looks like, okay, video number 0, Python, image processing, OpenCV. Video number 1, machine learning, classification, scikit-learn. So this is the end result from this exercise of video concepts. So for each of these videos, we are extracting these concepts, and we are just basically capturing that as you see on the screen. So these are all returned to the next level, and now let's extract video topics. What did we do here? We actually created a similarity matrix, and we did basically this is a processing of your video data. And now the next step, once that's done, is extracting the video topics. So what main topics are there from the video title and description? So what is the topic for that specific video? Again, if you're doing this manually, you are defining it manually. You don't need to go through all this exercise. You already define it. In this case, we are loading some unknown number of videos, and we are trying to automatically extract these titles and descriptions. And here I am manually defining, if you look down here, the topic keywords as Python basics, data structures, image processing, machine learning, blah, 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 whatever. And then I say, hey, for Python basics, it belongs to Python basics if it has something similar to these words, like Python basics, introduction, variables, functions, loops, conditionals. If it has all of those, then call it Python basics. If it has image processing type of keywords, image and microscopy or bioimage, then categorize that as image processing and so on. So this is done by looking for specific keywords like I just told you in the title and description. So in this case, like if the input is text is introduction to Python image processing, this is the title. And the description is learn how to use OpenCV for microscopy, blah, blah, blah. That's the description. We combined everything. And the output is basically, hey, this text corresponds to, or this video corresponds to Python basics, image processing, computer vision. These 3 categories, these 3 topics. So our goal here is for each video, assign the topics that the video corresponds to. Okay, I think that makes sense. And that's exactly what that short function actually does. Next thing, so these are all metadata for a specific video. What we are trying to do is we know that, okay, this is node number 0, node number 1, or video number 0, 1, 2, 3, but we need to add attributes to it, and then we need to define the edges between different, and we're slowly inching in that direction. So one of the attributes is difficulty. How difficult is this video? Because if you're doing prerequisites, you may want to go from a basic introduction video or a beginner video to a mid-level to advanced, right? So for that, inferring is important, but how do you infer video difficulty? This is where my numbering and other things come into picture. But first, let's go ahead and look at the title itself, and we are going to look for words like introduction, basics, or beginner, or what is, and then if any of those are in the title, then it's going to return beginner tag, or it's going to assign a beginner tag for difficulty. And if the words are advanced and expert and complex, it's going to assign advanced. Otherwise, it's going to just do intermediate. Similarly, if the video number is less than 20, then it's a beginner. Greater than 50, it's advanced. Again, these are just arbitrary numbers I put. Of course, there are other mini topics within these video series. So it's not as simple, but we are kind of simplifying it as much as we can. And also we'll look at the concepts, right? I mean, if you look at the concepts, if the concept count is less than 5, it's only like Python basics or something, right? Then it's a beginner. But if the concept count is greater than 10, like if it's like covering multiple topics, then we say that, hey, this is advanced, otherwise it's intermediate. You can set your own rules based on what you're trying to achieve, but this is what I decided to go with. In fact, it does make sense for us to run this block if I haven't already done so, right? I mean, we talked about all of these. So let's go ahead and run. These are a bunch of functions, nothing to run, so we are fine. Okay, so we did this, and before jumping into the next block, let's go down, we did this, we covered the infer. Okay, now we are ready to build the knowledge graph. And let's go ahead and run this while it's pretty fast. And to build the knowledge graph, obviously you need video data, right? So the video data is a pandas data frame that's actually going in. And we also are providing similarity matrix as an input, which is nothing but our NumPy array, and the video concepts, which is a dictionary we from earlier. And I also included something called similarity threshold, and I set a value to 0.6. That's and this is the threshold is when you're building edges in an automatic way, you want to build edges above certain threshold. Hey, I'm confident above certain threshold, these two belong together, then you kind of connect them. That's basically the threshold. You can play with that. So we are using NetworkX. Again, watch the last couple of videos if you don't know what I'm talking about. We are going to build nodes and edges. Nodes are nothing but our videos, and they have various attributes, metadata like difficulty and topics and so on. And edges are added based on similarity that we calculated, the cosine similarity, and which is basically semantic similarity between the video embeddings, right? So you have a video embedding for video number 1 and video number 25, and look at the cosine similarity. If the similarity is above 0.6, it's like, hey, let's go ahead and connect them. That's pretty much it. Yeah. Okay. So that is pretty much it. And how are we going to do it? And we are going to define a directed graph right there from NX, and these are all directed graphs. And to this, we are going to add nodes and edges. And how are we going to add nodes? First, we are going to extract the topics. I mean, nodes is pretty straightforward. We'll check that in a second. Did I do it right away? Video topics. Yeah, down here, sorry. I should be wearing my glasses, but yeah. So first thing, before even adding the nodes, we need to first extract the video number, right? So that's the first part we are actually doing right there. And the topics is another attribute that we include. And how do we get the topics? We already looked at the function that gives us extract video topics and infer video difficulty, right? So that's another thing we add. So here you go. So adding the node, our ID is nothing but the video number or video. I mean, that's our first ID that we are going to assign to each video, not the video number, sorry. And it could be video number, but in some cases I skipped the videos. the numbers for some of the videos. Okay, and we are going to, what attributes are we going to assign to each node? The title, description, the concepts and topics, difficulty, duration, and video number. These are all the attributes. And based on these attributes, we can later actually run our algorithms to create a learning path. Hey, for a given topic, which means look at the topics, right? If the topics exist for that node within this topic, go ahead and look at the video difficulty. And if the difficulty is beginner, put that in the front first, and then the advanced, put it in the last, and other videos in the middle. And also based on the video number and the duration and concepts. We can mix and match. We can run algorithms on these and try to create these learning paths ourselves, right? So that's the reason why we need to capture all of this information here. And edges are based on similarity and relationship. So all we are doing is look at similarity matrix. Like you have like one embedding and another embedding for each video. Hey, what is the similarity between these two? And if the value, we already saved the matrix, right? Similarity matrix. If the value is greater than or equal to similarity, some sort of a threshold, in our case 0.6, then go ahead and add an edge and determine the relationship between these edges, which we'll see in a second, but that's basically how we are adding the edges, g.addEdge for each of these edges. Okay, now what does determine the relationship mean? So it's basically determining the relationship between these two videos. You have video number 1, video number 2. So what is this relationship? Is it a prerequisite? Is video 1 prerequisite, or is it an advanced? Like, is it the next level, opposite of prerequisite, let's say? Or are they kind of related? You know, they don't have like a strict order, but they're probably related, let's say. And they're based on video sequence number, like I mentioned earlier. If it's part of a series, then it's a video sequence number, and difficulty and topic relationships. I already mentioned about it earlier. So there you go, your video number 1, video number 2, you have your nodes and you have your metadata. And for each metadata, if there is no video number, then go ahead and look at the next stage and so on, and compare the difficulty levels. And also if this is less than the video number 2, the number, then it's a prerequisite. Otherwise it's advanced if it's greater than. If it's not less than, greater than, if there is no number or something, then it's related, but it's not prerequisite. Okay, now that we defined our graph, did we run the, yeah, we did run the cell. Now we are using PyVis for visualization. I'm not going to go through the visualization code a lot, but one thing I should mention is you can define a lot of parameters for plotting, including what color you want your nodes to be, including what is the height and width and what type of font color, and physics also. Did I define that anywhere? Yeah, there you go. Like what type of physics, you know, like how stiff you want these networks to be. So when you pull on it, you know, there's a lot to talk about when it comes to visualization. I'm not, again, an in-depth expert on PyVis. I know a few things, and I have like previous code that I always copy paste and say, hey, just update this, because I spent time 5 years ago in coming up with a few of these visualizations based on my need. And I just, maybe there is an easier way to do that, but I just use pretty much the same content throughout whenever I work with graphs. Look into this. I mean, look into PyVis. It's amazing. It's amazing, the type of visualization, because we are human beings. We look at stuff and we make decisions. No matter how many algorithms you run, nothing beats looking at stuff. And the prettier it is, the more informative we think it is. So yeah, make it pretty. Make these plots look pretty. Okay, so that's it. I'm basically, in this case, this is what are we plotting? Visualize the knowledge graph, the entire knowledge graph. In this case, we have so many images. People usually don't look at the entire knowledge graph unless it's like only a handful of nodes. We have lots of nodes. So I'm saving this, but I may not open it on my old crappy laptop, maybe on a nice workstation. But I'll open some of the other ones, and so we can see. Okay, so I'm coloring beginner, intermediate, and advanced in like different colors right here, as you can see. And that's it. I mean, not much. And when you hover over a node, it's going to display the title, the topics, the difficulty, and all that stuff. That's what that part of the code is. And I'm going to save it as an HTML file, which we can open later on. Same with visualizing learning path. We will actually create a learning path later, which is nothing but a list, right? So you have 400 videos and you say, hey, show me the learning path for someone who wants to learn bioimage analysis using Python coding, for example. Then you have to start somewhere, right? So you have to start with beginners and so on. And then, so the learning path is nothing but, hey, the video numbers are 1, 2, 3, 4, 5, 9, 12, whatever. So that's your list right there for learning path. And this is just visualization. So this is exactly same as visualizing the graph that we saw earlier, except it's a subset of that. We are only looking at a path. That's it. So that is something we do almost at the beginning right there for each of these in path. Go ahead and extract those nodes from our graph. And from that point on, it's just getting the title, difficulty, duration, blah, 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 and go and plotting them. Okay, very similar plot as the earlier one. Same with the next one. Visualize the topic subgraph. Well, instead of the path, now we are actually filtering these based on the topic. Again, the first thing we would do is for each of these nodes, go ahead and get the topic. So I may have done, yeah, right there. I created a subgraph from the main graph for only the topic nodes, whatever the topic is. And we are getting those nodes up here. Hey, these are all the nodes for these topics. So go ahead and create a subgraph just by using those nodes. And from that point on, I'm just plotting a subgraph. That's pretty much it. Everything else down here, very similar. And visualize simplified graph is also very simple. When I do simplified graph, that means you pick like one of these topics and then just go ahead and plot that. So this is the simplified, for example, Python basics. Yeah, so just go ahead and plot only the simplified graph for that. And this is just plotting, so I'm going through, there's no point in explaining line by line, I guess. And now let's go ahead and do some analysis. In the last video, I showed you how you can get centrality, different types of centrality used like Python built-in functions, methods within NetworkX. I'm not going to do that a lot here. We are going to use just the logic that I mentioned, right? I mean, learning path is nothing but, okay, given this goal, what is the optimal learning path? And this is obviously the basis for our recommender system, right? So how it works is takes a learning goal as input. So you can actually type, hey, I want to master Python for bioimage analysis. So this is literally what you type, right? And an embedding is created from whatever you typed here, exactly using the same approach as before. We converted our title and description to embeddings, right? So that's exactly what we are doing. And you probably guessed the next step. You take this embedding and you match against all the nodes that you have in your graph. And then you kind of pull together whatever is relevant. And that's how you're actually converting the goal into embedding and SentenceTransformer, and compare this with all the other video embeddings to find the relevant content. And I should mention, I also added something called, for topic prerequisites. You have a topic and you need prerequisites. First, we manually define prerequisite relationship between topics. And why are we doing that? It ensures that before a learner is shown advanced videos, like when you say machine learning, let's do some prerequisites, like image processing needs Python basics and data structures. Machine learning needs Python basics, data structures, and data analysis. You can do some intelligent, use some of the intelligence from NLPs to automate this process. But in my case, I know that, okay, these are the videos I covered. So I am going to say for bioimage applications, you need Python basics and image processing as the prerequisites. So it kind of starts from here and then it builds on top of it. Okay, so that's basically the topic prerequisites. And how the path is constructed. Well, it starts with foundational content, which I just talked about here, based on the topic, and automatically includes these, like I mentioned, and sorts the basics by video number to maintain like a logical progression, and also adds topic specific content, similarity scores to find most relevant videos based on what you asked for, and then checks and includes prerequisites before, the ones that we define here, before adding the next level ones. That's pretty much it. So this is your goal. You're converting your goal into an embedding. and you're looking for similarities using cosine similarity between all the embeddings, and then these are the prerequisites. And once you have this, it's basically looking at the other logic we just talked about. And at the end of it, it basically returns the path, which is nothing but a list of numbers, which is your videos. Okay, once the list is returned, what do you do with just a list? Nothing. You just format the learning path. So you take that list as an input, and you already have your graph right there, and you go through each of those nodes and you extract the information and you just format your learning path. So this is nothing but formatting. Okay, like how many total number of videos? What is the length of your list? Is the total number of videos, right, in your learning path. For example, the total duration time. You know, each video, each node, one of the metadata is in minutes, how long the video is. You add all of those, and that's the total duration in minutes, basically, you know, to achieve your learning goal. And difficulty levels breakdown is what we print, and unique topics covered and all that stuff. Okay, so that's that part. And of course, the next part is just printing it, printing the learning path by loading the formatted path and just printing it, going through each part of the dictionary and printing the results. And the next step is analyzing the path coverage. Like what topics are covered as part of a given learning path is basically what this part is answering. So which topics are covered in the path, all the necessary prerequisites are included, for example, it checks. And I also added a warning saying that, hey, this prerequisite is not covered. Again, it's up to what you want to do with your specific content. So basically, at the end of the day, the example output would be, hey, these are the covered topics. I think this function returns 3 things: covered topics, prerequisites, issues, not prerequisites, and the topic sequence. Like here, you can see Python basics, data structures, machine learning are the covered topics. Well, this is the sequence of these covered topics, and the prerequisite, it says, hey, advanced topic found without Python basics coverage. So it's just a warning. Okay. And it's nothing but basically extracting information from your nodes. That's pretty much it. And now creating a recommender system. So it creates and initializes complete recommend system by running previously defined functions. So all I'm doing here is, so far we defined so many different functions, and everything kind of comes together here. Excuse me. So we define our transformer model right there with this model, and our video data. We are going to load the video data. This is the first function we defined, and then we are going to apply this process video data onto the video data we just loaded, and that unwraps like 4 different things like process data, embedding, similarity matrix, and video concepts. And of course, these things go in as an input into building our knowledge graph, and it returns, this function returns the knowledge graph and the transformer model and the embeddings right here. Did I run the functions before this? I mean, the block before this? I may have, but sometimes I just skip through and then it throws an error, and I spend half an hour trying to figure out what's going on. Thanks for your patience, guys. We are almost there. I hope you're learning something along the way. Okay, now I also included how to serialize your graph into a SQL database. Of course, you can save the NetworkX and then load it. There are many other ways of storing this. I talked about RDF in the last tutorial, although I do not have a lot of experience using RDF, very minimal experience. I know of it, and I don't have like a hands-on experience on it, but I always do NetworkX or basically a SQL database. So here, I'm going to show you SQL database right there. So we are going to create a database and create our output directory function. Let's run this actually and create the database. We are going to use SQLite 3 library, and we are going to create this database, and we are going to convert our nodes and edges and embeddings into our tables, and basically to the database we are adding them as different tables, as you can see right from there. Okay, yeah, that's all about creating this database, and then we have to save the recommender system, in this case saving as serialized database that we just created, and we are going to basically save that, and that's it. There is nothing more tricky there. And I have another function to save query results, like I mentioned at the beginning. All the text files, I'm saving them as text whenever I run a query. So I just call this function when I run a query and say, hey, save the query results, and it takes the results and dumps into a text file. That's pretty much it. And loading a recommender system. Okay, now you saved it as a serialized SQLite database. Now what? Obviously you need to load it. So here we are loading the database, but we're not just using the database as is for querying, because what's the point of actually creating a graph if we are going to work with database? You may as well create a database. The whole point of creating a graph is we ask the questions that only graphs can intuitively answer. And for that, I'm going to open the database, but again, create a NetworkX graph. So this is a way of showing you that, hey, you can actually serialize and save it and then load it, but then you can, you should create your own, the NetworkX graph again, if you want to run NetworkX algorithms, for example, on these graphs. And this part is basically adding the nodes, adding the edges, reading this stuff from the tables, and then just adding them. That's it. Okay. So, and then the question is, the next part is querying the videos by topic. Here, I'm directly querying the database and not the graph. As you will see, we are loading the database here, and the query right there is, hey, we'll look at the results in a minute, but we are running a SQL query right there. So we are selecting the ID, title, difficulty, duration from nodes where 1 equals to 1. I don't want to go through SQL right now, but yeah, this is running a query directly on your database. If you're not comfortable with SQL, like I still am not, I am getting better at it. But if you're not comfortable, you may as well work with the graphs directly, which we will right after this function, I promise. So this one, get video prerequisites, is again working with, are we converting this into, no, I see the SQL right there. So we're not converting this into graph, we're directly querying the database. So this is again just to show an example. So in this case, we are actually querying the source nodes that are linked to our target video, and basically looking at, is there a tag called prerequisite? If so, that is a prerequisite. That's pretty much it. Okay. Now for the next part, this query, get learning path from database. I should change this from database part, because we are loading this. You see, the first thing we do is load recommender system. If you remember, the load recommender system function loads it from the database, but converts that into a graph right away. So basically, we are building a graph right there, as you can see. And then once you have the graph, we are going to end the embeddings, because we are storing embeddings also as a table. Once you have the graph and embeddings, and then the user types the goal, we are just using find learning path. Remember, we defined this earlier. We defined this function earlier. Excuse me, where the goal text is converted to an embedding and matched against all the other embeddings, and then returns a path, which is a bunch of numbers, and that path goes into your because we are formatting the learning path along with the graph, and then formatted learning path, and then we print, right? And we print the learning path. So that is that part. And here we are initializing the system. This is basically the recommender system. So far we showed all of those functions. First, initially the core ones, and then the other ones that are pulling these ones. And this is the one where most of these things are coming together. As you can see, okay, we are creating the output directories. We are creating the graph by calling the create recommender system from the previous block that we just saw, and the input is our CSV path, and then we are saving the recommender system, and we are actually visualizing the graphs, and part of visualization is saving the graphs into a HTML file. So this is the key meat of everything. So let's check prerequisites. We already defined it. All I'm doing is running the function that we have already defined. Hey, this is my specific video ID, whatever the ID is, and get me what the prerequisites are for that specific video. Okay, Get path for the goal, again, same thing. We are running the function get learning path from database, and we are actually giving a goal, and it's giving us the path we talked about, the path earlier, so no point in talking about it, losing my mind. I guess it's longer than half an hour. Thanks for your patience, guys. And explore topics, again, query videos by topic is what that basically means. We are running that, and based on a specific topic, and run example queries. So let's give a couple of queries. Remember, again, these are the queries we run, and then we save it into text file. I'm giving two queries. One is mastering Python for bioimage analysis. The other one is learning machine learning for microscopy. Let's see what it actually ends up giving us. And all I'm doing is running for each of these queries. Go ahead and run our learning path, basically, right? So that is done, and I think let's go ahead and run it. And now actually, okay, my path for the CSV is right there, and this is just executing the code that we just looked at. Load the recommender system and run example queries, right? So we should see now stuff happening on the screen. Let's hope. Okay, so it's creating the output directories, and it should download this model, and it's loading the video data, and it's performing these in batches, like these embeddings. So it's creating the embeddings. So basically you'll have a matrix of these embeddings, and it should be pretty fast. It's not like we have a lot of text, but still probably GPU helps. I haven't tried GPU on Colab for this, but I didn't see the need anyway. So it should be a few seconds. So let's stare at the screen, and we should see results being saved into results directory after that line, basically. So let's come back to that in a second. So now it's extracting the concepts, and let's see. I mean, I'll probably pause. There you go. It got scared. It happened pretty fast. Everything is happening very fast, and it's all done, and it sees all operations completed successfully. So these are all probably the learning path for a specific goal that we have. But let's switch to our results, and let me reload, and hopefully we should see our directories. There you go. So the database is stored under database, and let's just have a quick look at our queries and see what the results are. So this is the learning path that's a pretty long path, right? So for mastering, let's check it out. Learning path for mastering Python for bioimage analysis. It is starting at what is a digital image, not bad, right? So what is Python? So video number 4, 5, 6, 7, and after 7, it skipped a few for whatever reason, and then 13, 14, 15, and then I like this actually. It included tips and tricks, because occasionally I do tips and tricks videos. This is where the video series get kind of upset. So this one is about all you need to know about decorators. I don't know why it put this. This is not a beginner. This is an advanced. Maybe because I put tips and tricks 17. This is where you can go back and say, hey, if it is tips and tricks, it's not a beginner or whatever. Let's see, where is it going? Let's just scroll a little bit. And most of my videos are structured for bioimage analysis, so I'm not sure, I'm not surprised that I see that. Now let's see, image prerequisites. What is this? Image processing intermediate. So intermediate difficulty. So here, interactive network visualization using PyVis. This was video number 316 that I have done probably a year ago, or probably 2 years ago. And so these are the relevant ones over there, but I think you'll be more excited about the visualizations. So let's go ahead and just look at the bioimage analysis. So what I'll do is I'll download these, okay, and then open them in a second. So let me go ahead and pause the video, and then I'll open because it may take a few seconds on my crappy old laptop. On top of that, I'm recording a video on it, so it's not going to be happy. So let me pause the video, show you the results, and then let's stop this video. So, okay, so this one is bio applications subgraph. So if I actually look at some of the clusters, let's say here, you see there is a cluster down here. And it says introduction to single molecule fluorescence in situ hybridization, obviously bio, and then SMFISH, and then transcriptomics unveiled, and then cell type annotation for single cell RNA-seq. So this is a path, and let's look at this path. Denoising MRI images, denoising images using, you see how even though the video number here is 94, this is 292, 294, it found all the denoising ones and it kind of clustered them here. And then here you see malarial cell classification, which is video number 71. But then in 128, again, you can kind of move these to have a better look. And binary classification, which one is this? This is using bag of visual words, image classification. Oh my God, I remember that. That was a long, long, long time ago. Okay, what is this one? That was like 5 years ago, I think, the video I did 5 years ago. And here you can see Python tips and tricks, best free software for image visualization, and then rich filters. So these, there's a central one right there, unit plus watershed for instant segmentation. One of my favorite videos. And these are all unit videos, as you can see. Semantic segmentation of mitochondria, large images by applying trained unit, and so on. Now, one more thing. Which one is this? This is the Python basics subgraph, and let's go ahead and just look at this nice one that's laid out right here. And this is introduction to pandas, and then introduction to pandas data sorting, data manipulation. So these are all pandas videos, obviously, and these loopy ones. So let's check these ones. And an introduction to time series forecasting, part 1, an introduction to time series forecasting, part 2, and so on. So you got the idea. And if I open the entire graph, you probably see a whole bunch of nodes, like all the nodes, and some are connected, some are not connected, some are like disjointed. And if none of those are connected, you may have to adjust the threshold to make sure some of these edges start connecting. Yeah, I think that's probably where I should end, because we can talk forever on this topic. But I seriously hope you appreciate the importance of knowledge graphs. And of course, I hope you learned something from this video and all the other videos that I have on my channel. Thank you very much, and do not forget to hit the subscribe button.